We need to obtain the value of derivative of y with respect to x at theta equals to pi over 3 radian whenever x and y are given in its parametric form. That means x and y are dependent upon the parameter theta. So we'll begin with whatever we are provided with. So here we are given x equals to a times secant cube theta. So that can be also represented as secant theta raised to the power of 3. And we have the value of y, which is given by a times tangent cube theta, or simply a multiplied to tangent theta whole cube. Now we will do is take the derivative of function x with respect to theta, which is simply taking the derivative of secant of theta raised to the power of 3. Here we can use the power rule to get 3 times secant of theta raised to the power of 3 minus 1, and since we have secant of theta instead of theta, we'll have to use the chain rule, so we'll multiply it to derivative with respect to theta of secant theta. This is going to give us 3a multiplied to secant squared theta times derivative of the secant function is secant of theta times tangent of theta, and that gives us 3a multiplied to secant cube theta times tangent of theta. This is the value of derivative of x with respect to theta. We'll label this as equation number 1. Our next task will be to obtain derivative of y with respect to theta, which will be equals to a multiplied to derivative with respect to theta of tangent of theta raised to the power of 3. Similarly, we can use the power rule also. We have 3 times tangent of theta raised to the power of 3 minus 1. This will get multiplied to derivative with respect to theta of tangent of theta. Here we have used the chain rule because we have theta tangent of theta here instead of theta. So this is going to give us 3a multiplied to tangent squared theta, and derivative of the tangent function gives us secant squared theta. So we have obtained derivative of y with respect to theta as well, and this is given by 3a tangent squared theta times secant squared theta. We're going to label this as equation number 2. Now our task will be to obtain derivative of y with respect to x. So to obtain this value, all we have to do is divide 2 with equation number 1. So that means we'll take derivative of y with respect to theta and divide this particular result with derivative of x with respect to theta. So this is going to give us 3a times tangent squared theta multiplied to secant squared theta, whole thing divided by 3a multiplied to secant cube theta times tangent of theta. So here a couple of terms will get cancelled out. We see that 3a from both the numerator and the denominator gets away. 1 tangent of theta from the numerator and 1 from the denominator goes away. Secant squared theta from the numerator and secant squared theta from the denominator also goes away. And this is going to leave us with tangent of theta divided by secant of theta. The tangent of theta divided by secant of theta, this ratio is simply sine theta. So we have obtained the value of derivative of y with respect to x. Now next task will be to obtain this particular value at x equals to pi over 3 radians, or simply at 60 degrees. So we have sine pi theta, so we're going to replace the theta value with pi over 3, and we know that sine 60 degree, that's simply root 3 divided by 2. So this is going to be the required value of derivative of y with respect to x calculated at x equals to pi over 3 radians.